This is a video about experiment analysis in Motif. We're working with the Motiflix dataset, which includes the kind of events you'd see with a video streaming service. In this video, we're going to cover how to identify the people in the experiment and do a basic analysis. There'll be subsequent videos that go into additional analysis of experiments in Motif. So the first thing we're going to do is find the users that were in our experiment. This is going to be different based on your data set and how you indicate that someone is in an experiment, but I think we have a pretty typical approach here. So we're going to match on an event called experiment exposure, and then I'm going to go down to our sequence model and shrink the prefix. That'll allow me to see all these experiment exposure events. When I look, I can see that there's an experiment identifier on here, which is the name of the experiment, Top Movies XP. This experiment was basically to add a feature called Top Movies. So when a user gets to the home page on Motiflix, they're going to see an area where they can go to see all the most popular movies. So I'm going to include that in here. So I'm going to say if the experiment exposure dot experiment equals Top Movies XP. Oops, there we go. All right, so that should select the same people. Now, one thing I want to do is take, also on that experiment event was the variant, so whether someone's in treatment or control. Right now that's on the event, and I want to pull that forward to be on the entire user record. So I'm going to add a value to the user that's called variant, or to the whole sequence record. We call it a sequence dimension, and I'm going to take that from the event exposure variant. So this is basically taking something from a single event in the whole sequence and making it a dimension on the entire sequence. And so we can see here's someone in the treatment control, and then people that aren't in the experiment. Now, of course, we want to limit to people in the experiment, so I can do a filter on matched, and this will only include people that satisfy the match requirement. So now we see only people in the experiment. And then I had reduced the prefix here with my sequence model, but obviously there's a lot of things that people did before the experiment started. And I want to remove that too. So I'm going to replace the prefix. Remember, all of that information before the first match is put into a label called prefix or a tag. So I'm going to replace prefix with null, and that's just going to remove it. And I love this about Motif is now I could just comment that out, and all of a sudden it's back. I can comment it in, and there it is. And we're working with 273,000 sequences, so this is moving pretty fast. And that's because we're sampling the data to give you something really responsive when you're working in the UI. And then you'll always be able to go in and calculate on the full set of data. Okay, great. So we have the people in the experiment, we have the variant that they're in, and we have only the data that happened after the experiment. Well, in this first analysis, we want to consider the impact on watch start. That's one of our most important signifiers that people are finding something they're interested in, that they want to try, is that they're watching a video. So I'm going to do something with Copilot here. I'm going to say keep only watch start events. And so I'm going to tell Copilot, and it's going to write the sol for that. It's going to do a match split on watch start. Now, it created a tag called watch start to label all the watch start events. These tags are just labels, and if I don't put a tag in front of it, it'll turn the event itself into a tag. So now I could just get rid of that and do watch start like this. So I'm doing a match split on watch start. So that's going to basically split every sequence every time we see a watch start. And then it's going to replace the whole sequence. Well, let me show you. So when I do a match split on watch start, you're going to see the watch starts for every user split up. And then it's going to also have a suffix because those are all the non-watch start events that happen between each watch start. And when I do the replace SEQ, I'm replacing everything, prefix, matched, and suffix with just the watch start. And then I can combine, and that's going to stitch all those back together. And now for each user, I have all the watch starts. Now the last thing we want to do is calculate the total number of watch starts for each user. So I'm going to create a variable called numWatches, or dimension. And I'm going to just use the length of the sequence. Now we wouldn't ordinarily be able to do this, but since our sequence is composed of just watch start events, we can just use the length of the whole sequence to get it. So now for every user, I have whether they're in treatment or control and the number of watches. All right, I think we're ready to do some basic analysis. So I'm going to pop over to plot. For my dimension, I'm going to select the variant. And automatically we're going to do a count star. And you can see this is the number of people basically in treatment and control. It was 80,883 in control and 79,935 in treatment. It's relatively balanced. It's possible that if I hit query more and basically calculate this across the whole data set instead of the 12% sample that I'm using now, they would be perfectly the same. But let's remember that for our analysis. So I'm going to change this dimension to the number of watches, and then I'm going to aggregate that as a sum. So this will give me the total number of watches on each side of the experiment. Now, if the treatment group were much larger than the control or vice versa, then this wouldn't really be a fair comparison. But if we're assuming they're control, I can see my lift in the total number of watch start events in the experiment. If I'm concerned about balance, I can do mean with error bars. And so now I see the treatment group has on average 20.4 watches. So people in the treatment group watch on average 20.4, after the start of the experiment. And then people in the control 17.6. So almost 3 additional watch starts we got from being in the experiment. If I'm concerned about outliers, I can check the median. And that'll just give me sort of the middle value for each. So 16 versus 20. So there is some outliers because it's about 4 now, the difference on treatment. So control was inflated a little bit by some outliers. I'm going to go back to mean with error bars. And then I'm going to hit query more. So this will now operate across the entire data set instead of my 20% sample. Now that I have the analysis I want, I can hit query more to get the final values for my experiment. And this is taking it's going to be about 10 seconds or so to look across this whole data set, 12 seconds. I don't want that kind of response time every time. So the sampling really helps you kind of move at the speed of thought. But you also have this flexibility to say, give me the final response. So on the treatment side, 20.3. On the control side, 17.4. So just about 3 additional watch starts for being in the treatment group and having that top movies experience compared with people in the control. All right, so that's the first video we have on experiment analysis. We basically defined the people in the experiment, and we limited ourselves to the data that was relevant to our time period. And then we limited our analysis to watch start events, looked at the total number for each user, and did some basic plotting. We'll do more in the following experiment videos, so hope to see you there.